Einstein found the equation E equal to mc squared, where m is the rest mass of a particle. This is a major discovery explaining why the sun can give us so much power. In fact, this process, which we call nuclear fusion, is a source of solar energy and much of the light that we see in the universe. So what exactly is nuclear fusion? Nuclear fusion here, we look at the example of fusing a deuterium, which is a hydrogen atom, with one proton and one neutron. Typical hydrogen we find only has a single proton, but no neutron. But deuterium is H with an atomic mass of 2, because besides the usual proton of a hydrogen atom, it also has a neutron. Also, there's another isotope of hydrogen, which is H3, which has not only one proton, but also 2 neutrons. Now, just a reminder, protons have a positive charge of 1, and a neutron has no electric charge. Now, deuterium and also tritium can be made to combine together to form a helium atom which has 2 protons and 2 neutrons. And in this process, where you originally has 2 protons altogether and 3 neutrons, and a helium He4 only have 2 neutrons, and therefore one of the neutrons is emitted. And altogether what you have is the formation of a helium-4, which carries another 3.5 million electron volt. And electron volt is the amount of energy that the electron will give or acquire kinetic energy as it moves through a voltage potential of 1 volt. So it's about 1 million electron volt, which is a relatively large amount of energy compared to the small mass of the helium atom. Also, it will emit a neutron with a large amount of energy, in this case here, 14.1 million electron volt. In order for that fusion process to happen, which has to do with nucleonic forces, the fusion would need to overcome the electric repulsion of the 2 protons, because they are both positive charges. And in order for them to bang into each other, overcome that electric repulsion of the same type of charge, you would need to make these 2 collide at a high velocity. And one way to make them collide with a high velocity would be to confine them in a very small volume and heat up these atoms to a very high temperature, exceeding tens of millions of degrees. The very fact that helium H2 and hydrogen H2 and H3 has a bigger mass make it easier for them to fuse together than compared to the case when you only have the ordinary kind of hydrogen banging into each other. So that's why in hydrogen bomb we don't use the natural form of hydrogen, but we use deuterium and tritium because they were fused together at a lower temperature than the billion-degree temperature required for the fusion of hydrogen atoms together to form helium. Now, let's have a look at why this process would generate energy. And the reason is that if you compare the rest mass of the deuterium as well as the tritium, you add the 2 masses together, by looking at the atomic weight of these two elements. And then calculate also the rest mass of the neutron plus the rest mass of the helium. You'll find that there is a loss of mass when these two particles are fused together to form the neutron as well as the helium. And if you use the equation E equal to mc squared, attributing the loss mass as being converted into energy, you would find that the loss mass times c squared will be a sum total of the energy that's acquired by the neutron as well as the helium, adding up to roughly 17